Hey, what's up, everybody? Welcome to TGIK, live in the Heptio studios. Happy Friday, everyone. Good to see you all. Looks like we already have some folks hanging out in chat, so we'll do quick intros and say hello, like always, my favorite part of the week. So let's see what we have here. Hello from Naperville. Hey, Sanket, good to see you again. Marco, our #1 fan, thank you for joining. Sean, Noah, good to see you guys. Paul. Looks like folks are talking about notifications. Hi, Keith from Scotland. Hey, Paul again. Hey, Sean again. So notifications, real quick. That's a great point to bring up. We do the tweets. You have the hit subscribe button. That'll give you the calendar kind of alert and push notification. If you do the YouTube thing, and it looks like some other folks have dropped in, like even gone as far as putting calendar invites to block off like an hour or so for TGIK. So thank you to everyone who joins. We're always happy to see you. Another one from Sean. Maybe Heptio Studios should pick up the expanse. Hey, Tarun, Suresh, Marco again saying hi. Justin Cook from London. Hi, Frederico. It's good to see everybody this week. So this week we're going to be talking about the operator framework that came out from CoreOS. And before we jump too far into that, we have a couple of updates. Hey, Jimmy, good to see you. Hey, Eddie. So let's jump over to our new and shiny TGIK repo and start to look at our updates for the week. Bam. Oh, I love how we have mountain pictures. So anyway, for those of you who missed last week, we do have a TGIK repo where we're going to start to track this stuff. Also, we found out last week on TGIK that this is actually really good for sharing links as well. So if something happens during the show and you want to share a piece of documentation or maybe share a URL with someone, you can come in here and go to our issue tracker and open up an issue. And we can build on that as we kind of go through this and we see how folks want to use the issue tracker here. But it's a great way for us to share and for me to pull stuff up as we're doing this live. Hello, everyone, again. Let's see. We have people from Bangalore and Bosnia, people joining from all over the world. So thank you, even if it is Saturday your time. We appreciate you joining. And for this week, we're going to scroll down to episode 37. But before we do that, we wanted to show that we were able to backport all of the episodes into the TGIK repo. Big shout out here to our friend, I want to pronounce your GitHub handle, Recoller, but it's Frederico who put together the old repository for TGIK, and he should be out here, I think next week or the week after. But thank you so much for backporting those. We have all of the old notes from the older episodes, and we got this new one, episode 37, that we're going to be looking at today. Hey, Angel from Cuba? Oh, north of Cuba. Okay, you're from Florida. I was like, oh, that's cool. Somebody joining from Cuba. So anyway, we have the link to the episode here, and then we have a couple of links that we're going to go through. I think it was a relatively quiet week in Kubernetes land, and next week we have a short week as well. So we're going to go through a couple of updates that I've kind of kept a pulse on, and if folks have anything else, feel free to open up an issue or mention it in the chat. So the first one was this Reddit thread in our Kubernetes, which got a makeover since we were last here a couple weeks ago. And it's just a nebulous thread that says, hey, what have you been working on this week? Which is relevant to the discuss.kubernetes.io thread that we saw last time with the update from the community call, but this is more of an open-ended question just to see what folks are working on. I started to read this and was like, oh, I kind of want to start to respond to some of these. Hi from Toronto. Roy, I'll be in Toronto next week, so it would be awesome to see you there. I'll be speaking at DevOps Days, talking about moving monolithic applications to Kubernetes and the woes contained therein. Bonjour from Paris. Hi, Mario. Good to see you. So anyway, the one that kind of jumped off the page at me is this bringing up a Kubernetes cluster in Azure, which is we totally did that last week, and I was like, hey, I figured out a good way to do that using the AKS command line tool. So anyway, if you don't know our Kubernetes, it's a good place. There's a pretty good moderation that happens there, and folks are just usually just happy to hang out and share tips and tricks if there's ever anything you want to work with the community on. So this next one was another post from our Kubernetes. This is a new tool out of Google called, I want to say Kasane. I'm not sure what that stands for, but looks like it's a definition of it. Anyway, it's not an official Google project, but I wanted to mention it because it sort of is working in the same space of Helm and Kasane. It also uses JSON to transform objects in the same way that Kasane does as well for deploying Kubernetes applications. So it looks like it's relatively new. Pip install Kasane here makes me think this is a Python project, which the setup.py would also imply that. So I haven't actually checked it out yet. I just saw it, and it looked like it was a new deployment tool, so I wanted to bring it up and just let folks know it's out there, and I like to kind of keep an eye on this stuff just to see if it ever takes off and wonder what was their inspiration, like what was different here that the other tools weren't offering that they wanted to encapsulate with this tool. So that's a cool one to check out. The other two I wanted to mention was KubeCon has CFPs open for anybody who wants to do public speaking. So there was a tweet, which you can go to here, that just mentions that the two CFPs, which I've put links to here, one for Seattle here, where the TGIK studios are, with Mount Rainier in the background here, and the other one is over in China, which this is the first time the CNCF is doing a KubeCon in China. So that's going to be an exciting first event for us over on the other side of the world. Anyway, Kelsey Hightower usually mentions to folks, hey, if you want somebody to take a peek at your CFPs, give me a call. I wanted to extend the same gesture. I have helped out a lot of people internally and some folks externally from all over the world get CFPs together for both KubeCon as well as any DevOps or enterprise-related conference as well. So feel free to hit me up on Twitter. If you want to submit a CFP and maybe are kind of confused or a little intimidated if this is your first one, I'm happy to share what little knowledge I have on the entire process. But yeah, it'd be great to see more people come out and talk, get some diversity up there, and get new folks who haven't been on stage before talking about Kubernetes, because this is really what we want, is different opinions here. So those are the two CFPs. Another one, talking with some of the folks over at SigContribX, there is a call for contributors right now. Both SigUI and Scalability are needing some help. So if anybody wants to get involved with committing to upstream Kubernetes, feel free to either ping me or jump into the SigContribX Slack channel, and you can get involved with working on the Kubernetes user interface, which is the Kubernetes dashboard, so front-end work, or Scalability, which is a lot of behind-the-scenes infrastructure layer. How do we actually look at solving scaling in Kubernetes and taking these already in place primitives and growing with them? And I'm going to pause really quick and take a quick look in our chat. Looks like we've had a lot of action here. Bonjour from Paris, we saw that one. LaMaddie, Container D 1.1. Oh, okay, so Maddie says Container D 1.1 was released this week. Maddie, if you want to drop a link or pull request into the repo, see how it's already working for us, we can merge that in and we'll pull it up on the screen. Cool. What else do we have? Sean says, try to create a CFP, seeing as I'm based in Seattle as well. Kaslin says, you're awesome, Kris. I'll take full advantage of your offer here. Sure thing, Kaslin. Also, it would just be great to see you again. Yeah, and Sean wishes you good luck as well. So anyway, we're here, and we're here to help. So feel free to lean on us. The other thing I wanted to mention was the operator framework tools, but I think we should do that one last because that's going to be a natural segue into the core of the program here. And this last one was this PR in the Go community that Russ Cox did for Go Buffalo. So there was a lot of controversy, and Joe kind of mentioned this the other day about Dep and VGO and this new tool, I think on TGIK, it might have been around the office. But for those of you who don't know, VGO has been coming into play. And I thought this was a really great example of the Go community giving back to the open source community as well. In this pull request, we actually had Russ Cox, one of the core maintainers of the Go programming language, open up a PR to an open source tool written in Go, trying to help ease the migration over to VGO. So there's some good stuff here, and it was just kind of inspiring to see somebody working on the Go project full time come back and go out of their way to open up a pretty lengthy PR here to help folks in the Go community. So I know poor Dep as well. I'm going to talk a little bit about Dep today because the operator framework uses it, and I was a big contributor, so it's going to be kind of sad to see some of my work go. But it is nice to see the Go community working together and at least trying to make honest efforts here, which I feel like is important to a healthy programming language. Okay, and without further ado, let's jump into the operator framework GitHub organization. Let's see, Sean says. put a lot of work in getting teams off of quite a few different tools over to Dep. That's not going to be fun. Well, hopefully with this PR and some more user experiences as well, we can come together and make the transition from Dep over to VGO a little seamless moving forward. So I helped with Dep originally, and I still plan on intending to help the community as much as I can. And I know I'm not the only one who believes in a healthy Go programming language. So I think we'll figure this stuff out. Anyway, the operator framework tools. Go ahead and pull this one up really quick. So the first one is the operator-sdk, which this is what we're going to spend most of our time talking about today. The other one is this Helm app operator kit. Now this one kind of like caught my attention when I first saw it. And this is a set of tools or templates for creating an operator from a Helm chart. And I'm going to draw a diagram here in a second, kind of talking about the differences between operators and controllers and Helm charts and kind of like where the boundaries are and how folks are kind of thinking about these, or at least how I'm thinking about these moving forward. But here's some tooling to help make that transition a little bit easier. Next, we have the operator lifecycle manager. This one's pretty cool because this is actually going to help you version your operator. So one of the big concerns folks have with writing and maintaining operators is how do we scale these things moving forward, and how do we do a live upgrade where we might have an API change and we have introduced new directives or remove some old directives, and how does the software respond to that? So this GitHub repository is aimed at making that a lot smoother as well. We have awesome operators, which is a list of operators out there in the wild, which I think this is open source, and I don't think this list implies they were created with the operator framework. I think this is just a generalized list of operators. The reason I think that is because I saw Heptio arc somewhere in here. I don't think they're alphabetized anymore. Yeah, here we go, Heptio arc, which I don't think was created with the operator framework, but still behaves as an operator. So I think if you have one or you know one, the folks here are tracking just generic operators created with or without the framework. All the way down to Zookeeper and CloudFormation. So there's a lot of them here. Going back, we have Getting Started, which we're going to look at this repo a little bit as we kind of jump into exploring the operator framework. And last but not least, we have operator-sdk samples, which this will be useful for folks when we get into the sort of nitty-gritty here of defining a spec for an operator, defining a CRD, and actually looking at implementing solutions to what to do when we are given one of these CRD structs in memory. So there's some good samples there. I think there's one for memcached, I want to say. Oh, Vault, I'm sorry. Vault was the example here. And we can go in and we can see what this one does. And this is actually a working Vault operator that you can go and deploy and run. So anyway, this is the operator framework at a glance. I think to start off, it's probably going to be useful here to define a little bit of vernacular before we move forward in the episode, which I'm going to switch over to my dock camera. Let's see. And bam, I love this little thing. I really want to start using this more and see if I can't find a pen here. There might not be a pen in here, in which case I could just use a Sharpie. Wait, here we go. Okay, so the three words we have right here are controller, we have operator, and we have, I'm going to call it a deployment. And a deployment is basically just a Kubernetes deployment. And I'm going to kind of put in parentheses here a chart, or a chart-like object, which is just a straight-up application. And the boundaries of these three things are kind of interesting because they kind of bleed into each other. So again, borrowing some verbiage from folks here on the office, defining a controller as just a generic or nebulous piece of software that sort of watches something and tries to reconcile that over time and kind of never gives up. It's the whole point of a controller there. Whereas an operator is domain specific, so it's going to be something that takes action and tries to reconcile some sort of arbitrary task that's unique or specific to a piece of software. And a deployment is just a very generic piece of software without any of that higher level management on top of it. So to speak concretely, let's say that we had a controller that all it did was try to manage a database. And maybe it had very basic create, read, update, and delete. It could create a database, bring it to life, could read if the database was running and maybe make small changes to it, and then delete the database after it was done. That, with Kubernetes, would look like creating a deployment, modifying a deployment, and ultimately deleting a deployment. The fact that it would be generic and it kind of works with any database or any deployment is what kind of makes it a controller. It's sort of ambiguous between what it's actually doing. Now, if we were to take that a step further, we could get a little more specific with an operator and say, instead of just doing all databases, let's just focus on MySQL. And let's focus on setting up MySQL slave replication and bin log replication and creating and modifying indexes in our different MySQL tables. And we're doing this domain-specific logic, stuff that's unique to a single piece of software. And then last but not least, the most fundamental piece here, a deployment, which just is our MySQL server by itself without any of that higher level management on top of it. So hopefully that kind of explains the differences between the two, how I think about them, and how I'm going to be using the words throughout the episode. And let's see, we have a few questions here. Justin says, whoa, high-tech drawing tools. I didn't really draw any pictures, I just wrote them down so I could point to them, but I do like using this camera. I'm going to start using it a lot more. And Felipe says, are all these resources useful for developing an operator controlling a custom resource description? That's a great question. Operator, to me, sort of implies there's some CRD at play here. Controller is usually like, if you look at like the various controllers in the Kubernetes control plane, those aren't really CRDs, although they behave similar to a CRD. Those are actually true proper Kubernetes primitives that the controller then acts on. Whereas an operator kind of takes this concept of bring your own definition, and then we can go and we can take a custom logic on top of that. And then again, the deployment, the most fundamental piece, without any higher level management on top of it. So hopefully that answers your question, Felipe. So anyway, going back to our screen here, let's get started with the operator SDK. So we'll jump into our repo here, and we're going to scroll down, and we're just going to do this quick overview. And I've got, let's make sure we got everything nice and lined up. Got my terminal here, and then I should have the operator SDK. Yes, I do. It's right here. Repository checked out. I think my font size is good. Going back. So we're going to kind of read through here, and this explains a little bit about what an operator is and why we need them, and explains why the operator framework came to be. And there's an introductory blog post that we brought up last week that sort of announced this whole movement moving forward. But basically, my interpretation after kind of looking at this a little bit this week, the operator framework just kind of takes the noise out of creating a new Go project to create one of these operators and defines like the basic level structs for you and gets you everything you need to like define your custom logic and your custom definitions for your CRD quickly and easily. And we're going to look at how it does that over time. And Nod Sharma says, just curious, what kind of camera are you using? I don't know, but I can find out, and I can open up a PR. I have the drivers here pulled up in front of me, but I would have to move the camera in order to find out. I think it's a Logitech, but I can send you a PR, or if you want to open up an issue, I can respond to the issue afterwards as well. Great question. I'm also curious. This is just what we had here in the studio. Okay. So the workflow here is to create a new operator using the command line interface, which we're about to do. We're going to define the API, and then we're going to specify some logic for the API, and then we're going to go and run this thing in Kubernetes. And here's our quick start here. So the first thing we want to do is we want to go into our operator framework directory, check out master, do dep ensure, and then we want to do a go install to get the operator up and running. So I've already kind of done a lot of that, but we can go to my go path. We can go source, GitHub, operator framework, operator SDK. We can do a dep ensure. I always like to do a dep ensure -v. The reason for this is interesting piece of trivia. I wrote the -v output for dep whenever you go and you actually walk through the tree and try to run the solver on top of your packages. So every time I run that, I kind of like, it's a little bit of nostalgia. I remember working in the dep source tree for a while, trying to get that PR up and running. So anyway, dep is now initialized, and we should be able to go install this. Let's see, we don't want to go install that. What's our go install command? Go install GitHub framework, or github.com operator framework, operator SDK. Let's run this command. And bam, that worked. So also, I went ahead and I did alias O is equal to operator. It's operator SDK is the name of our. So now I should be able to run O. Bam. So instead of having to type operator SDK every time, we can just go ahead and type O, which I use K for conductal, and we'll use O for operator SDK. And it's a very familiar Cobra command line. output here, and it tells us all of our different commands for the operator framework. So now that we have the command line tool up and running, we actually want to use this on a new repository. Let's read what Paul says really quick. Kate's operators to me basically seem like a way to potentially automate away a good amount of toil that many SREs have to regularly deal with. +1, I think that's a great definition. I think the word operator itself, if you think about a human operator, somebody going and managing software from like a higher layer perspective, I think writing software to do that management to me is really like why I believe the word operator is a good term to be using here. So yeah, anyway, if other folks have other definitions of operators, we'd love to hear them. And we can even start a list of things that sort of define what an operator is in the TGIK repo if we want. Anyway, back to our operator SDK. So I've created a new GitHub repository. And just to confuse people, I've called it kubectl. So we're going to go to github.com/Kris Nova/kubectl. Is that not what I spelled it as? Maybe I created a different repo here. Oh, I spelled cube, K-U-B-E. Okay, so this is a private repo, but this is where we're going to write our code for today. And then when we get done, I'll push it up and we'll open source it. And it will be available for folks at home to look at. But this is just going to be a basic operator as we use the operator SDK to get one up and running. Also, we have a very basic KubeCon cluster already created, so we can do a kget nodes, and we should be able to see that we are running version 10.3 Kubernetes cluster in Amazon using KubeCon and the new cluster API controller as well. Okay, so we're going to go to my Go path, and we're going to go to github.com/Kris Nova/kubectl, not kubectl. And this should just be, yeah, it's just an empty repo with a readme.file that says it's literally called kubectl. So we can do whatever we want to here, and this is going to kind of be our sandbox for the course of the episode. Okay, so the first thing we want to do is we want to pull up our operator documentation here. So here we have create and deploy an operator using the SDK CLI. So it says go into some example directory. In our case, we have kubectl. And we're going to run this command. We're going to run operator-sdk, new operator, and we're going to define the API version and the kind. So to do that, and I'm going to hashtag this out so we have it in our bash history here, we want to kind of tweak this command a little bit for our using. So we're going to do operator-sdk, and instead of calling this app operator, we're going to call it the TGIK operator. And for the API version, we want to do app.example.com. We're going to do TGIK .heptio.com, which is important here. Your operator will run into trouble if you don't have a period delimited API group defined here. And we can go ahead and start with our v1 alpha1. And for our kind, this can be anything. So this can be an idea that's important to humans. This could be an app, it could be a server, it could be MySQL, it could be anything that your operator is going to represent that's important to you and your organization. So in this case, we're just going to call it kind is equal to, I guess we can do TGIK. We might want to change that later, but we'll see. We'll see how this plays out. I haven't really thought much about what our operator is going to do yet, other than flip some bits and spit out different log messages. But if folks want to see anything, I'm happy to live code it as well, if anybody has any ideas. So anyway, we'll start off with kind equal to TGIK. Okay, so what's going on here? It looks like some familiar commands. We've created some files. We're running dep ensure. Here is the solver tree output that I wrote that I'm so deeply proud of. And it's dep going, and it's actually running dep on this newly created directory for us. So we'll give this a few minutes to run, and then we're going to go look and see what would happen behind the scenes in our kubectl repository. So now it looks like it's writing some vendor files, and it's doing the code generation for custom resources, which if anybody who's ever messed around with the Kubernetes CRD code generation libraries before know that this is a huge win for us, that it's happening kind of automagically here. Okay, so it looks like it's done, and it's initialized an empty Git repository in my higher level kubectl repository. So interesting to see how this is going to push up. I think it might even get committed as a Git submodule, but we'll see. And I think there's actually a way, if I remember, we did operator new. We can do operator new.help. Yeah, we could have passed in the skip get init flag here, and it would have bypassed that last get initialization, which a way to undo that would just be to delete the hidden directory get in the subdirectory there. So anyway, let's look and see what's going on in our repo. So we have a new folder called TGIK operator. And if we go into that folder, we can see that we've got our 2 Go package files that Dep created for us. We've got command config deploy pkg temp and vendor. Now these look pretty familiar to anybody who's ever poked around the Kubernetes codebase before, and this is a pattern that you see a lot in both github.com/Kubernetes and most of the other sub-projects and SIG-sponsored projects as well. So do I have tree installed? I do. So I can tree our command directory here. And we can see we have our main.go. And I want to tree our package directory as well. And you can see here we have 2 subdirectories. We have the API directory and we have the stub directory. In APIs, we have the name of our API that we defined. Remember earlier we did kind equals TGIK? This TGIK here was populated from that string we passed in earlier. And then we have our API version, which in this case is v1 alpha 1. And if we wanted to version our API, we would have another directory there, maybe v1 alpha 2 or v1 beta 1. And there's some interesting semantical reasons that these APIs are called this way, which we can do a whole other TGIK on the Kubernetes API constructs in the future if needed. So anyway, this is pretty cool. It went and it generated our API and our main.go for us. And it kind of did all of the dependency management and importing all of the Kubernetes libraries for us as well, which has kind of been tricky, for lack of a better word, over the past 6 months to a year of trying to create these operators over time. I wrote one for KubeCon a couple months ago, and I remember spending most of my time just getting everything to kind of play nice together, and then spend about 2 hours actually writing the little bit of custom logic on top of that. So the fact that this is already done is pretty interesting. So I want to kind of go and see what happened here when we ran that new command. So in order for us to do that, let's pull up the operator-sdk program itself. And remember, we used this program to generate our new program. So we have 2 programs at play here. So here in operator-sdk, we don't have a CMD directory, but we have a commands directory. And I bet if we drill down in here, yeah, there's our CMD directory. Awesome. So we did operator-sdk new. So I'm going to guess operator-sdk new. Yep, this is our command right here. And then we passed in a project name, which was TGIK operator. So this is the Cobra command definition, and it looks like we're defining our entry point here as new func, and we can hear some flags that we can define as well. So I bet if we scroll down to new func here, we can actually go and look and see what the program is doing behind the scenes. So the first thing it does is it calls parse on the arguments. Interesting. And it pulls the args out of our slice in memory. And the next thing it does, where's our new func? Here it is must be new project and verify flags. Let's look up must be new project, which is here. So it does a file path join, and it does an exit with error. What's going on here? If error is not equal to nil. Okay, so all we're doing here is it just validates that this directory doesn't exist and that we can go ahead and create a new project here as well. I want to get into like the depth stuff, so we're going to kind of look around and see if we can figure out how it's calling dep and doing everything else. Looks like Paul had a question. Heptio/Kris, your Terraform cuddle ideas as an operator for auto-scaling K8s clusters might make an interesting operator, but also might be a bit too much to take on in a 1-hour hack session. Totally agree. And after playing with this earlier this week, I've kind of already thought of a couple of operators, Terraform cuddle included, that I kind of want to just like make so that we have them as a community, so that when we get into these questions like, how should we vendor the Terraform binary? I can just point to a repo and say you should just use this operator instead. But good call, and I think that might be a bit much for a 1 hour hack session. So anyway, let's look at this pull dep command, because I want to see how we're actually interfacing with the dep library here. Aha, so this is what I wanted to see. Okay, so we're calling fprintline, and we're passing it to standard out, and we're saying run dep ensure, and then we're actually doing this exec command here. And it looks like, I bet if we go and we look up what this constant is defined as, yep, just as I suspected, we're actually doing an exec wrap around dep. So there's probably documentation on this. Let's go look and see. Let's grep for dep and see what happens. Deploy. See the user guide maybe. Yeah, here we go. Okay. So in order for the operator framework to work, you need these tools on your system, and they're going to do a command exec on each of them. So you need to have dep installed, you need to have git installed, you need to have go installed. Okay, so we're not actually vendoring a lot of these tools as a library. We're actually just doing an exec on your system. So bear that in mind for folks at home. If you want to start using the operator-sdk, you're going to need to make sure that you have these dependencies managed before you actually try to create a new prototype application as well. Okay, so let's go back and look here in our directory. So we've called operator-sdk new. It's created our basic Go files for us, and it's also done all of our vendor dependency management for us. And it's done dep to do a checkout, and it's initialized a new Git repository. And I bet we can start to take action on our repository. But let's go back and see what our documentation has to say. Okay, so it says after you have ran the new command, which we have here, you can change directory into your new operator, and then you can actually do an operator-sdk build. Let's see, we have Medi says, maybe simpler idea, maintain a set of endpoints exposing processes on the K8s nodes, example, Prometheus node exporter. I think that's a great idea. Again, I don't know if we're gonna have enough time to jump into exposing processes running on the Kubernetes node in this episode, but I'm happy to like print some stuff out and do some diagnostics from memory if we flip a bit, just to demonstrate that we can control the operator remotely from a CRD. So maybe we can go down that path of just doing like a simple diagnostics output on the system that it's running on. So anyway, it looks like the next step is to build and push our operator up to Kubernetes. And in this case, I think the example operator is probably fleshed out enough for us to go ahead and build it and push it up there and just see what it's doing out of the box. So to do that, in our newly created directory, we need to run operator-sdk build, and then the name of the image we want to save our operator as. So let's go in, and we're in our TGIK operator directory here, so we can do operator-sdk build. I'm configured to work with Docker Hub, so I'm going to type my Docker Hub username, which is Kris Nova, and I'm going to call this TGIK operator, and we're going to give this the tag latest. So this should build a container image for us, but let's just run this and go look at the code really quick and see what the code is doing as well. So we did a build command, so if we pulled up the source code in the operator SDK for build, I'm already seeing we have some build, Docker build, and config YAML constants defined here. I'm going to guess that this just wraps some logic on my local file system. Yep, looks like we have exec command docker build. And it looks like docker build is defined in relative directory temp build docker build.sh. So in order for us to open that, let's open up our kubectl repository here. Bam, get that out of the way. And I bet we have a directory in here called temp. Sure enough, we do. And what were we looking for? We were looking for temp build docker build.sh. So these were outputted from our operator-sdk binary. We have docker build.sh. So it says, if not which docker dev null, then Docker does not exist. So that's a pretty classic bash one-liner that'll check and see if Docker is installed on your system. And if it's not, it'll yell at you and say you need to install Docker, and it'll exit with a exit code of 1. And then it moves forward and it says, let's define our image. And then it says building container. And then there it is on line 11, good old docker build -t, the name of our image, and the Docker file to use, which is temp build Docker file. So let's go in here and see what the Docker file looks like. Okay, so we're building on a basic Alpine container. We're running add user -d, TGIK operator, and the user is TGIK operator. And then we add temp output bin TGIK operator, user local bin TGIK operator to our Docker as well. Neil says, something that was not obvious when I first started playing with the operator SDK, operator SDK up local will spin up the operator on the local development system. Oh, that's interesting. Let's try to run that after we build our Docker image and start pushing it up to a Docker registry, but I want to see exactly what that user experience is going to be like. Okay, so let's see what we did here. We ran operator SDK build, and yep, here is our Docker output here from our Docker command line tool that we're wrapping with the operator SDK binary. And it says successfully tagged Kris Nova TGIK operator with our tag latest. So I bet I can just Docker push this, but hold on, I don't want to jump the gun here. Yeah. Docker push, and then it looks like you just pass in the name of your image there. So we should be able to do Docker push, Kris Nova TGIK operator latest. Sweet. And we're pushing up our Docker image here. So I bet we can go to Docker Hub. Should be logged in. Awesome. So we just like that created the TGIK operator down here at the bottom. New repo. I'll give it a star, just so I get that email that says somebody started your Docker repo. And I bet if we go to tags, yep, we have our latest tag. Okay, so this thing's 11 megabytes, so not huge. I've seen some controllers, cough, the KubeCon controller, that are several hundred megabytes in size. So this is pretty cool that it's pretty lightweight. This is going to be important because that means we're going to be able to pull this down into Kubernetes quickly, which is going to be handy in the case of some sort of outage or failure. Bringing the controller back quickly is usually pretty important to kickstarting another chain of events of your cluster slowly fixing itself or regaining stability as well. Oh, sorry, Jimmy, I don't use Quay. I just use the Docker one because I was able, really this is the reason why I did it, because I was able to get the Kris Nova username, which to me was just like, okay, that's going to be easy for me to remember, so I'll just go with this one. But I have used Quay or Key in the past. That's what we used when I was working at Deas before Microsoft, and it worked great. I totally had great user experience using that as well. Okay. So we have our image pushed, and I bet there's a way to deploy this in Kubernetes if we go read our documentation here. Okay, so it says deploy the app operator. So it's telling us to create these 3 YAML files. We have an RBAC one, we have our custom resource definition, and then we have our actual operator.yaml itself. And it would not be a TGIK episode unless we went in and we looked at some YAML of what our documentation says for us to do to our Kubernetes cluster. So the first one it said we should do is install RBAC. So let's see what's going on here. Sean Smith says, Quay is great unless you try to administer it on site, then it's got issues, but I use it for my personal projects. I never had any issues with it. I've also seen folks who have created their own Docker Hub registries. I mean, I think it's a personal choice. I think everybody's going to have reasons why they want to do one over the other. But thanks for the good feedback there. So in our RBAC YAML here, we are defining a role. And it looks like we have our RBAC authorization, kates.io, and v1 beta 1. And here is the name of our operator that we're going to start to use. I'm guessing all of this stuff was populated dynamically, and it created these YAML files for us, which is pretty rad. So the first API group that it defines, or the first rule it defines, is for the API group tgik.heptio.com. Remember I said earlier we needed to have that period delimiter in there, so glad that it filtered through to RBAC YAML here, and we're opening up all resources with all verbs. So the operator will be able to take action on any of the verbs to anything in the same API group, which is handy. For the core API group, we have, looks like all verbs for pod services, endpoints, persistent volume claims, events, config maps, and secrets. Seems pretty straightforward for opening up the core API group. And then our last one here is for apps. We can access all verbs on deployments, daemon sets, replica sets, and stateful sets. Jimmy says, if you want to let me know what issues you ran into, Sean, you can email me. Awesome. Thanks, Jimmy. And then we have a role binding here for our default service account that just maps it back to our TGIK operator. Okay, so this RBAC seems like it's a great starting point. I'm really happy to see that we even went as far as to define the RBAC as well. This is a question I always ask folks, like, do you have an example of deploying this application with RBAC? And usually the response is something along the lines of not yet, or coming soon, or it kind of works for me. So really cool to see that this is dynamically creating like good RBAC rules for us to start with, which is important, I think, to get this right. And one of the more challenging things for folks who've never worked with RBAC before is defining something like this. So giving you a starting point is helpful. Also, a friendly reminder that everything in RBAC is like enable only, so you don't have like a deny all set of rules. So these are everything that is turned on for us here in our cluster. Cool. So we can go ahead and apply this RBAC rule here. Or yeah, we want a was it K apply or K create? K create. So I think we can do a K apply, but we'll go ahead and follow the documentation here like good open source citizens. Okay, so we'll kubectl create. -f deploy RBAC.yaml. See what we get here. Okay, so we have our role defined, our TGIK operator was created, and we have our role binding default service account, or default account TGIK operator created as well. So next it says we want to kubectl create our CRD.yaml. So let's go and look and see what this CRD looks like. So this is the custom resource definition that the operator-sdk created for us. So pretty standard CRD definition here. We define our group. We have TGI-Kates and TGIK, so I can do kget TGI-Kates or kget TGIK. I think it would actually probably be a little more appropriate to do that string, but we're going to keep it semantic for now. So it's scoped into the namespace, and we're using the v1 alpha 1 API, which of course is going to be defined here in our v1 alpha 1 API definition as well. Okay, so we can go ahead and apply the CRD. So we can k create -f deploy CRD.yaml. Okay, so we created our CRD. Let's look and see what CRDs we have defined. Okay. Oh, this was me tinkering a while ago. I can probably delete my unicorns one. K delete CRD unicorns not found. There, TGIK.com. Okay, so now we have kget CRD again. Good, we have our clustered machines that were defined with our KubeCon cluster, and we have our TGIKs TGIK.Heptio.com CRD as well. So I bet if we do kget TGIK, no resources found, but I bet we're going to go create one here in a second. Okay, so we've created a CRD. That was pretty easy. We're 45 minutes into the episode. We've already been able to create a new repository and deploy a CRD built from our Go source code. So this is kind of exciting. Let's go back and check out our documentation. So last but not least, we want to do k create -f deploy operator.yaml. So let's go take a look at our operator, which I have a feeling is just going to be a pretty basic Kubernetes deployment. Okay, so we have an API version apps v1. I think this might give us a little trouble in KubeCon, so we might be updating this to an extensions v1 beta 1, I want to say. We can look it up later. And we have our name TGIK operator. We're going to be deploying one of these. It's going to give it some labels. And the container definition here is, populated dynamically. Kris Nova, TGIK operator, latest, and image pull policy always. So this looks like a pretty great starting point for a deployment for us to run our operator in. So I bet we can k create -f deploy operator .yaml. See what we got here. Okay, so yeah, this is what I was afraid was going to happen. So let's look and see what deployment API we're using in our kube system namespace. So we can do kget deploy -namespace kube system. I'll pipe that to grep, and I'll grep for API. Let's see what that returns. We want to YAML that. There we go. So yeah, we're using the extensions v1 beta 1 deployment here, so I'm going to make that match. And I see folks talking. Give me 1 second to get this deployment installed, and then I'll go check our chat and see what we're saying. Okay, so we have our extensions v1 beta 1 deployment. Let's try to run that again. Bam. Now we can kget deploy. Oh, there's my unicorn operator. Let me delete that. Just trying to clean this up as we go so that we're only looking at one thing moving forward. Delete that deployment, and let's get deployment again. Okay, so now we have our TGIK operator that we just defined, and let's see if there's any pods up and running. So good. Our deployment is destroying our pod here. Okay, so we have our TGIK operator pod running. Let's look at our logs and see what's going on. Klogs, bam. And let's do a -f just for good measure. Okay, so that's tailing our logs. Let's go and see what's going on here in chat. Can one of the Corios folks answer this? The SDK reckons Docker version 17.06 is required by OpenShift. Paul says, gotcha, I was just wondering if I missed something, to be clear about OSS. Sean Smith said, yeah, I haven't had issues with my Claire. My main issue is someone submits a ticket to the main repo, and I need to explain how to give it access to help, even though I'm a server admin. Okay, so they're still talking about the Quay user experience. Okay, anyway, there was a good question earlier. Can one of the Corios folks answer this? The SDK reckons Docker version 17.06 is required, but OpenShift uses Docker 1.13. Any ideas how this will be adopted for OpenShift? I think that's a great question, Alan. And if you don't get an answer here in chat, I think this is a great example of us to open up an issue in the TGIK issue tracker, and we can start to ping folks on GitHub and use that as a resource for people who might have the same question moving forward. Paul is chiming in here. I'm not from Red Hat CoreOS, but if you aren't already listening to their PodCTL podcast, you might want to listen. Okay, so check out the PodCTL, PodCuddle, PodEctol podcast. There's a lot of pods going on there. Okay, so anyway, we have our operator up and running. It hasn't really done anything yet. It looks like it's just hanging. So let's see if we can't get our operator to do something exciting. So let's come down here to our Goland. Actually, let's go to our documentation and see what they say is next. Okay, by default, creating a custom resource triggers the app operator to deploy a BusyBox pod. So in order for us to do that, we do kubectl create, and then we have a custom resource, which is one implementation of the custom resource definition that we defined in our previous command. So let's take a look at that YAML and then go ahead and run that command and see what our operator does. So we look at our cr.yaml here. We have kind TGIK. Our API version is tgik.heptio.com/v1alpha1. And our metadata name is simply example. We'll call it TGIK live. And hopefully we can pull that back through the terminal later on downstream. Okay, so let's apply this. Let me split screen. Oop, go back there. Zoom in here. And I can resize terminal magic, clear that one. Logs are on the left, but we should be able to kubectl create -f deploy our custom resource. Let's see what happens. Let's go to our correct directory here. Go source github.com/Kris Nova, my GitHub username, / what did we call this thing? KubeCuddle. God, it's so confusing. Okay, so now let's rerun our command. Deploy cr.yaml, the path deploy cr. Because I need to go into our TGIK operator directory. Now let's try this again. Okay. Okay, so tgik.heptio.com TGIK live was created. I didn't see anything happen here in the logs, but let's get pods and see what happened. kgpo. Let me scoot this over, because we really don't need to see our logs. We just need to see if they move. Okay, this is great. So our operator is running here as a pod in the default namespace for 3 minutes, And we just created a new custom resource, and it looks like we have a BusyBox pod that was created. The BusyBox pod is just basically a pod that runs and doesn't really do anything. So let's get logs and see what's going on there. BusyBox. Okay, that should do it. No logs. But if we get our PO, yep, it's still up and running. And I bet if we do kget TGIK, yep, there's our TGIK live. And I bet we can come in here and we can change this to TGIK live 2. And I bet we can get another BusyBox pod up and running. Kget PO. Let's watch this again. Ooh, interesting. So it's only going to create the one BusyBox pod? We gave it a separate name. Okay, so I think this is probably a good place for us to jump in and actually look at the operator source code and see what's going on and see how we can't change this to make it do basically whatever we want. Okay. So in order for us to look at how this is being handled, we need to kind of understand how the operators and controllers themselves work, which is via a watch, which is an etcd primitive that kind of helps Kubernetes and Kubernetes software keep an eye on some sort of resource and take action when that resource is updated, which is pretty cool. And that's sort of like one of the big responsibilities and big reasons we have this declarative infrastructure that we do. Okay, so if we go into our package, we can go into stub, and we can open up handler.go. And this is going to be our handler for the operator. How we know that is we go into our main.go, and we can actually see the main function for the operator as it's running in a container in Kubernetes. So the first thing we do is we print version. We define our resource and our kind, which I'm going to assume these two strings were dynamically created. And then we have these three functions down here at the end that say SDK watch, which is the watch that we talked about, SDK handle, and SDK run. Now this SDK package is sort of the meat and potatoes of the operator SDK. And as we actually look at working on our handler, we're going to be able to explore all of the different functions and common uses and handy conveniences that the SDK package has put together for us. Because we don't have to really care about things like authenticating with the cluster or getting our client Go up and running. This kind of builds that framework for us, which is pretty handy because when we look at our handler.go, we have these structs that are defined that say things like fill me, and like new handler just returns an empty handler. And we could put arbitrary values here that are going to be relevant to our handler as we build it out. And we can access those as a method internally on the handler itself. Real quick, since we're looking at a data structure with the method handle on it, this is a good opportunity for me to bring up a really great piece of information around the differences between methods and functions in the Go programming language. So to me, I've always thought of a method as a part of a class, and that's like the old object-oriented software engineering me talking. In Go, however, we don't really have classes, we have structs. But handle is associated on the handler struct, and usually when you see a method, this would be called a method, not a function, because it has an associated data structure with it. Usually when you see a method, you want to take some sort of action on this internal data structure. So in this case, we have h, which is our handler, and we're not really taking any action on it yet. As we start to build out whatever logic we want to, some people suggested doing Terraform for an operator. We had somebody who wanted to look at pulling some different resources about the node as an operator. We could start to put handy convenience pointers in here that like pull information and store it in memory, and we can start to take action on those moving forward. So it's pretty cool that they've generated all this for us straight out of the box. So the first thing we have is we have this handle function that takes a context. +1 for using a context, great to go. Love good context, it's very idiomatic, and I think more and more people, especially in Kubernetes, are finally coming around to the fact that we should be passing the context into most of our methods and functions here. And then we have an event, which is an SDK event. So in our SDK package, if we look up what an event is, it is an object that is of type object. And here we have type object, which is a type of runtime object, which if you go and you actually look at runtime object, this is going to be, if we scroll all the way up to the top, the Kubernetes author. The runtime object is this generic object type. It's similar to inheritance that you would see in object-oriented programming, but here in Go, I'm drawing a blank right now, we call it embedding. And I think, what's the other word? Maybe extending. So anyway, all of the Kubernetes objects, deployments, pods, services, they all have this runtime object as the core part of it. So as we pass one of these interfaces around, we can sort of unmarshal that onto, or untype that onto whatever type of type we actually expect it to be. So if we go all the way back here to our handler.go, we see we have this switch command. So the first thing that we're doing here, and this is going to look a little weird if you haven't actually seen it before, is we're doing a type switch. So a switch works because you have some condition. In this case, we are calling the O is equal to the event.Object to whatever its type is. So this is Golang's way of defining to return what the type of a interface is behind the scenes. So the first case statement here is on line 26 that says if it's a pointer to v1alpha1.tgik, run this block of code. And if we actually ran this code, which we did earlier, it's going to call this SDK create new busybox pod, and we're going to pass in our O, which is of type TGIK. So in this example, we could do O, and we can actually see that we now basically are treating O as a pointer to v1alpha1.tgik, which I know it's a little hard for folks who are seeing it for the first time, but I think it might make a little more sense if we came down here and we said, we added a new case statement, and we said v1alpha1.tgik's list. And then we defined some logic here. So now we can look at O, and if you notice O here is actually different than O here. It's because it's treating the same object O, which is an interface runtime object, as two different types. So whatever type it really is, we're going to run that corresponding block of code for that pointer in memory. So it really gives us a pretty clean interface here for us to pass in a lot of different types of objects and define one handy top-level method that's going to sort of break apart the different objects so we can do different things. So as our controller is given an event, it's watching, remember our CRD, of v1 alpha TGIK, we can go and take this code path. But if we were given a TGIK list, we could go take that code path, which is pretty handy because now you have one controller that can do a lot of different things, and it does each one of them atomically. So you're going to actually be able to operate on v1 alpha 1 TGIK before we run a different switch statement in this single go routine moving forward. So anyway, I know that was a lot. So if folks have any questions about the different types of pointers you can have in memory there, please drop them in the chat and I can come back and revisit this. And we're actually going to build out a few of these and kind of jump a little more in depth here. And this looks like a natural stopping point, so let's see what folks in chat are saying. I always like checking out the chat. It's like, what has everybody been doing? Why I've been brain dumping for the past 10 minutes. Okay, so we had a question, what does context.context mean? Andre, composition, thank you. That was the word I was looking for. So in Go, composition is the concept of taking one struct and composing multiple other structs into and out of it. And I've done a blog post on composition before, and there's sort of some unique ways about how you can access different fields in memory and how it sort of like spoofs the struct to think that there are actually higher level directives that if you try to declare it literally aren't really there. So if anybody has any questions, feel free to hit me up and I can give you some composition examples that sort of demonstrate the differences between the two. So anyway, to answer your question, context is a way to propagate cancellation. So yeah, so when we pass in a context here, we can pass in different types of context, and our function would be responsible for respecting those two different types of context. And I bet if we go and we look up one of the operator-sdk samples, we can see an example of the vault operator, one of the other operators, using different contexts. Let's see. So operator-sdk samples, here's our vault operator, package, stub, handler.go. So we pass in our CTX context. Oh, and they just have a different package called vault reconcile, and they don't pass in a context, so not respecting the context. But anyway, there's some other great blogs out there as well. Dave Cheney, one of our folks here at Heptio, has a really great one that explains context and why it's a good idea to pass that into a method in Go. So anyway, going back to our source code here, we now have our TGIK list that we're going to comment out of the way, and we're going to have our v1 alpha TGIK, which right now does an SDK create, and it calls this new busybox pod. Let's see what this function does. So this is a function, not a method, because if you look, it's not taking action on an existing struct. So we have a new busybox pod that takes we call it a CR, but it's a v1 alpha 1 TGIK pointer, and returns a v1 pod. So a v1 pod is a Kubernetes definition of a pod in Go. So this definition here is called a literal definition, meaning that we're actually declaring everything in one fell swoop, which is why we have the return right here. And we're populating all of our different values for this data struct in memory right here in one fell swoop. Another way of doing it would be first we define the pod, and then we set type meta equal to this other struct that we've previously defined. And then we sort of like drill down into the struct that way. I see a lot of folks doing this because it looks kind of neat, and you kind of see everything in one glance. This is how we do all of our profiles in KubeCon as well, so that it kind of becomes almost a weird configuration file where you can come in and you can do things like if you wanted to change the name to busybox to busy TGIK, you could totally come in and do that. We define our kind is equal to TGIK and our owner references. We pass in some labels. And then last but not least, we have our containers, which is called busybox, and our image is busybox. And we pass in the command sleep for 3600. So it's just going to sleep for 3600 seconds, and then it's going to go ahead and exit, and Kubernetes will reschedule it again. But to put it into perspective, I could come in and I could change this to Ubuntu or even Nginx, and we would pull the default Ubuntu or Nginx images as well. We'll keep it as busybox because we're going to get rid of most of this method. Function moving forward. Okay, so we had a question from Moody. Hey, Kris Nova, do you know of a way to exec into one of the containers using the operator-sdk? We had somebody bring up using, what was the comment earlier? Let's see if I can scroll up in chat. They found a command that allowed you to replicate it on your system. But yeah, we can totally exec into one of these pods. And by exec, I mean we're just going to open up a bash terminal in one of these pods, which I can do that right now. Let me show you how. Let me pull my terminal up. So we have our pod running. Let's see if it's exited yet. Okay, it has not. So we can, well, actually, we're not going to do the busybox. Let's do the TGIK operator. So we do kexec into here. I think we do -it. Actually, I think we need to follow the Docker syntax here. So kexec -it TGIK operator, and then we do bin bash. Let's see what this thing does. Starting container process called exec bin bash stat, no file or directory. Let's just try bash. I think this is an alpinism. Bash not found. Is shell found? Can we just do a shell? Yeah, there we go. Okay, so it's got a born again shell, but not, or it's got a shell, but not a born again shell. So anyway, here we can actually explore a container, and this is what's running in Kubernetes. So we can go and we can actually see. We have bin, we have dev, like let's go poke around the home directory. And hey, there's our TGIK operator, and nothing's running in here. Yeah, Alan says bin sh. Okay, so anyway, this is how you can exec into a pod. So now we can actually go and explore and see what the pod's doing. I think we can even, I'm not sure if this works in Alpine, but I think we can do, we can't do ps-ax, but can we do ps-aux? Perfect. So yeah, we can see that we have the TGIK operator running, and we've got our sh shell running, and of course the ps-aux command I ran that has since exited, and we've gone back to stack. Okay. Oh, so the question was, in Go, how do you exec into one of these containers running in Kubernetes? So there's a couple of ways to do that. Using the Docker libraries is the only way I've ever been able to do it. Kubectl does it, so you can do. You can go look and see the source code in Kubectl to see how they're doing it. I even think the old Deus workflow project also had a remote exec library as well. So there's a couple of different ways. If you want to ping me offline, I can give you a quick code snippet that would basically replicate in Go this experience here, and you would be able to interact with the container remotely that way. Although there's going to be a lot of dangers with doing anything like that. The second you start looking at execing into containers, the second you kind of open up this like Pandora's box of security concerns. But curious to learn what the use case would be there. Okay, so we're getting a little derailed here. So anyway, exiting out of our shell there, we can come back And let me see if I can pull up my IDE again and look and see what we have going on here. So let's just do a simple change, and then we'll push that up and validate our change is working, and then we can define some more API directives for our operator here as well. So I'm going to comment all of this out, and I'm just going to do a simple print line. We received a TGIK, and then we're going to copy this down, and we're going to do print line TGIK. What else can we do here? We have TGIK specs. Let's do list, and we received a TGIK list. Cool, and we can get rid of all of this, and we can even do some quick debugging here. Printf. So we're going to do our object, which will do %+v, which is very descriptive. And then we'll do a new line, and we'll pass in O. And we can just echo out our object each time. Cool. And actually, you know what? For good measure, let's do a new line, so we can see every time we create a CRD pretty easily on the screen. Okay, so this is just some simple debugging, one of which for a TGIK API and one of which for a TGIK list, which again, reminder, those structs are defined here in types.go, TGIK and TGIK list, which of course just has items, which is a list of TGIK items themselves. And again, a lot of this is auto-generated, and we have this TGIK spec and status, which we're going to come back to these in a second, because this is really the core of the operator. Being able to define arbitrary logic in your spec, and to be able to report back, this is critical, report back to the status of what these different objects represent with a TGIK status. And here you can see it says fill me, which means we can define whatever we want. We can have a list of int32s, a list of strings, pointers to other objects, you name it. We can start to build these out with ideas that are going to be important to us in our operator, which is pretty cool. Okay, so going back to our handler, we have now defined some new controller logic. So let's see if we can actually redeploy this in Kubernetes. So sorry, my taskbar changed. Let me see if I can move it up here. I know you guys can't see this, but it's been driving me crazy. Okay, we'll just move on. Let's go back to our operator SDK and go into the user docs and see how they do an update command and redeploy to Kubernetes. So we can go operator SDK. We can go down, where were we at? We were on a quick start, and then here's this user guide. So this is operator SDK master. Okay, so it's in the doc directory. Okay, so what we want to do, customize the operator logic. So this is what we've been doing sort of naturally here in the episode. And this is in the context of memcached, which I think is one of their example CRs. And here is, yeah, so we're kind of caught up to this tutorial already. So they're doing a watch, they're calling a stub new handler, and they're doing an SDK run, and they're passing in the to-do context, which basically means we'll just do it and hope for the best. So in this example, they've defined a directive, which was int32, and a slice of strings, and this is the command we're looking for here. Okay, so now we want to, after we've made a change to our controller, which we have done real time in my IDE here on the side, we can run this operator SDK generate K8s command. So we pull up our iterm, and we do O generate, so let's see -h for help. Okay, so we have K8s, which generates Kubernetes code for a custom resource, or we can do OLM catalog, which will do an OLM catalog manifest. So let's go ahead and do O generate K8s. So it's running the code generation for our custom resources, which those CRDs, again, being defined in the APIs directory in Go. I'm tying my shoe right now, so give me a second, everyone. And it generated our deep copy funcs for us as well. So we have the Kubernetes code generation out of the way, and our CRD and CR have been updated. So I bet we can now do an O build. Kris Nova, we call it the TGIK operator. We'll call latest, so we're going to clobber our previous tag. This is pretty convenient. I'm already kind of like getting the flow of things. Like, oh yeah, now we're just going to build it with the O command. So we built our container, and let's Docker push that. I bet actually I have it in memory here. Nope, I don't. Okay, so Docker push. what was it, Kris Nova slash TGIK operator with the latest tag. And so remember in our deployment here, so this is going to come in handy. Where is our, no, not temp, deploy. In our operator.yaml, we defined a deployment. And here we had image pull policy always. So we actually don't have to delete the deployment and reinstall it. All we have to do is kill the pod. And then the scheduler in Kubernetes is going to come in and say, oh, for the deployment, we need to always pull the image, so it's going to pull the new image, and then poof, our new controller should be up and running. Or excuse me, our new operator should be up and running. So let's jump back in our terminal. Okay, so we've pushed our Docker image up to our Docker registry. So now let's kget PO, TGIK operator running for 20 minutes, and let's nuke this PO. Bam. And let's try this again and see what we have. So container creating, we have a new one. So our logs broke over here, so let's re-pull up our logs here, because these are going to be really relevant to us. I'm hoping that from print line, that OS standard out is going to work here, but we'll see what happens. So let's kget PO. Let's pull our logs for this pod. Klogs bam minus F. Oh, this is real cool. Okay, so yeah, we received a TGIK. Okay, so it's watching this every time. So I bet if we come in and we kget PO and we kget TGIK, so we have TGIK and TGIK2. So this is just catching up here. So let's give us a nice big empty space. Oh, okay, so it's going to be rerunning this every time. Interesting. Okay, so the way the watch is working is we're actually getting a TGIK for 1 and 2 every time, every iteration. So let's see if we look at our main.go. Resync period. I bet that's what we're seeing here. What's our resync period? Let's go actually pull this in loop and look it up. Oh, so resync period equals 5. So I bet if we actually count, we're going to see 5 seconds between a TGIK and a TGIK 2. So yeah, so if you look here in our little definition of our %+v, we have TGIK live 2 defined here, and then we have TGIK live here. So I bet if we delete this CRD, k delete TGIK live 2, and if we delete TGIK live, I bet now we can watch our operator. This is pretty cool. Do nothing. So let's give this a few seconds to make sure it's working. Perfect. Let's see what folks are saying in chat. Thanks, Chris. Good to see you here. Felipe Martin, the handler is called when you create, update, or delete a CRD for each CRD every X seconds. If I remember well, you define the X in the main.go. Yep, so that's what we just looked at. Paul says, for what it's worth, I personally avoided using one-letter shell aliases, even though I'm super lady, since it sort of seemed to make my command R history practically useless, which is exactly what we just saw here on my screen a few seconds ago. Yeah, so I think 2-letter minimum is probably a better practice to have. I just like it for the live streaming episodes. But good tip, Paul. Thank you. Okay, so yeah, we've been able to demonstrate that without any CRDs defined, the operator actually isn't going to do anything. It's just going to wait. So we're not actually going to get that watch resync that we saw earlier. But if we create a new CRD, let's open up this CRD.yaml. We're going to call it, I'm sorry, not our CRD.yaml, our custom resource. Let's call this TGIK live 3. And let's go ahead and apply this here. So k, we need to follow the rules. K create minus f, deploy cr.yaml. And I bet, poof, bam, that was really fast. That was really cool. So you saw how fast our operator was able to detect a new CR and take action right away. So already, we could be having custom software that's doing whatever we want for whatever definitions are defined in the CR. So I think the big thing we want to demonstrate now is how to actually start adding directives to our custom resource definition that we can then trigger on in our code and then redeploy that and rerun that in Kubernetes. So let's go ahead and delete the TGIK live 3 CR, and then we'll make a code change, repull our image, and then run it and see if we can't start to flip things around and make interesting things happen. Okay, cool. So k delete TGIK live 3. Bam. Let's go ahead and get us some nice good clear space here to remind us that nothing's happening for our operator right now. And let's jump back in our IDE and start to make stuff happen. So we can go into our package APIs TGIK v1 alpha 1 directory now, and we can jump in our types.go, which is where we have a spec and a status. So let's just do some custom logic here. So we're going to call, we'll create a new Boolean. We'll call it TGIK demo. We'll set that equal to a bool. We'll be good API Samaritans, and we'll define our JSON lowercase as well. So we're going to call that TGIK, we'll camel case it demo. And I think, what's the syntax here? We want one double quote there and there. I think that's what we want. Okay, so TGIK demo bool, and then for a status, we're just going to have a status string. So we'll define that as a string, and we'll say JSON is equal to double quote comma status lowercase. Wham kablam. I seriously, I don't, like, ever since that conference when I heard somebody say wham kablam, I can't stop saying it. It's a really bad habit I need to break because it's kind of annoying me. Anyway, TGIK demo and status string are defined here. And again, we could sort of like, we could, you know, make whatever directives we wanted to in our struct here, or I'm sorry, fields to use proper Go idiomacy. So, you know, we could have my int 32 is equal to type int 32. You know, we could have like a my pointer is equal to a pointer to, you know, some struct defined somewhere. So we can start to really build out these really complex TGIK specs for our operator for whatever's important to us. So if we were writing a MySQL operator, maybe this is something like use MySQL bin replication, or the MySQL bin replication size limit, or any of the other configuration values that you would define for your MySQL server. And so for Cassandra, for Kafka, for any of these other like more complex orchestration like systems that we need to orchestrate, we can come in and we can start to define API directives that are sort of our own custom abstraction on top of the software behind it, and the operator goes and kind of sprinkles its magical management powers on top, which is pretty handy here. But just for the demo, we'll just have a simple bool, and we can just demonstrate how to rebuild it, and then how to make our operator change as we move forward. So we have TGIK demo, and we have our status. So if we go into our stub handler.go, we can go in and we can say, okay, we received a TGIK, and let's like kind of hack in here. Let me draw us a couple of lines so we can kind of see this new piece of code, easy for folks at home. Bam and bam. We'll keep the stuff here at the bottom in case we need it. And here we can say, so if, remember O in this case is going to be a v1 alpha1.tgik pointer. So we can say if O spec, there's our TGIK demo bool, is equal to this. We can print line, hey, we have our Boolean set to, we'll do all caps, true. We give it an exclamation point because we're going to be excited there. And then else we'll go ahead and just add some simple logic here from print line. Hey, we sadly have our Boolean set to false. Cool. And then just down here at the end, we're going to keep that stuff commented out of the way so that we can just see if we're setting something to true or setting something to false. And I bet just for good measure, we can go ahead and we can print the name of our, let's do it up here, the name of our CR every time. Funct printf, let's see, the name of this CR, and we'll put it in square brackets. It's going to be a string, so we'll use %s, and we'll do a new line afterwards. And we'll come in and we're going to do o dot name. Cool. So it'll print the name, and then it'll say we have our bool set to true or false. So let's go back to our terminal. We're going to run our generate command, generate Kates. Running code generation for custom resources. Generated deep copy funcs. Let's go back here and look in our deploy directory. And for metadata, we have name is equal to TGI Kates, and I bet we can come in here and we can do spec TGIK demo is equal to false. And our CRD still looks good. Okay, so we'll call this one TGIK live false. And let's go ahead and destroy this pod and see what happens. So we'll destroy the pod. We will repull the logs on the left side, and we will install the CRD with set to false. We'll install one for true, and then we'll update it and see what happens later. So let's go ahead and let's destroy this pod. K delete PO, name of our pod. Bam, we should lose our connection here on the left, which we did. K get PO. This one is running, so let's grab this name, klogs -f. Very good. We don't have any CRs defined right now, so our logs are doing nothing. Let's get us some more black space so that we can see when something happens easily. And let's k get TGIK, no resources found. And let's apply, I keep doing that, create -f, what was it, deploy cr.yaml. Kind of nervous to see what's going to happen here. TGIK false was created. Okay, so it says here we have received, oh, I know what happened. This is our old image. We forgot to build and push our image. Let's do that really quick. Okay, so let's delete TGIK live false. We'll recreate you in a second, TGIK live false. Sorry about that. So we want to do our O build command. So we did O build, one letter O in bash history. Bam, just worked. Doesn't really ever always work, but it just worked then, which was exciting. Let's see what folks in chat are saying while we're waiting for this Docker push. So let's look at our bash history and do Docker push. So wait for that to go up. Folks in chat, you don't need in your tag or comment in your tags. The comma is split so the name from the flags. The double quote is for optionals. Okay, so folks are commenting on my JSON declaration there in the struct. Okay, you couldn't run it outside the cluster, so you don't have to rebuild the Docker image every time you make a change. Yeah, so Reinhard has a really great comment here, which I could actually just run the Docker image locally. I'm just running it in Kubernetes so that we can get in the habit of seeing how we're going to access the logs and kind of interfacing with the rest of Kubernetes. But yeah, you could totally run this operator locally. Also, I think that the operator is going to have some special magic behind the scenes so that it detects that it's running in the cluster that could help us out as well. So anyway, so we have this Docker build and pushed, and now let's go ahead and destroy our pod. And we'll reopen up our logs here. Okay, get PO. So this would be a really handy alias to have in bash right now, which would just be to look up the pods and open up logs for the one that you want to. But we can go ahead and just do klogs, the name of our pod -f. Okay, so here's our new code change. Okay, so the name of the CRD or CR is TGIK live false. I thought we deleted that one. Let's go and let's see what's going on in our CRD here. Okay, get TGIK. So TGIK live false. So let's do this. K edit TGIK TGIK live false. Yeah, that looks right. Okay, pull it up in Emacs here, and I bet we can come in and we can set name is equal to TGIK. We're going to change the name of our CRD. Oh.
That's PowerShare's S&P 500 EQ.
Siri just turned on as I was talking about CRDs. Okay, so TGIK live, we want to call this true, and we want to do TGIK demo here. Let's set this to true. And save that, and let's see what our controller does on the left side over here. We sadly have our bool set to false. Interesting. Oh, we got an error here, that's why. Error, TGIK's live true cannot be found on server. The edits you made, deleted resources have been saved. Why did that not work? Oh, did I type the wrong? TGIK live false, TGIK demo is equal to false. This should work. Let's try this again. Set this to true, and TGIK live is equal to true. Cannot be found on the server. I don't think I did a typo. Let's see what folks are saying. Yeah, you typed TIGK instead of TGIK. By the way, for folks who might not know yet about the FCF Go CLI tool, so Paul has another comment on another tool there. Why could this not be saved? Anyway, here's what we can do. We can kget PO. We'll do this the hacky way. So we can delete this. Oh, not the pod, I'm sorry. Kget TGIK. We want to delete this one. Kdelete TGIK. TGIK lay false. Okay, so it was deleted. And you can see it here. It said default TGIK lay false is deleted, so it's not taking any action now. So now let's go and let's recreate a new TGIK custom resource. We'll set it equal to true. Flip our bit equal to true. And let's go rerun this again. Where's our create command? Deploy cr.yaml, so that should do it. Okay, so yeah, now it's echoing true. So interesting. I wonder why that kedit command was not wanting to work for me. But anyway, this does demonstrate that you are able to flip a bit defined in your API here in your types.go, and you change how the operator behaves arbitrarily. Furthermore, you can actually keep the same operator running and just mutate CRs as much as you want, and the operator will detect those every time. So that you can just go ahead and declare whatever you want, and the operator will always be able to pick that up and take action. So I think to really give us a nice mature operator here, we want to update our status as well. So let's do this really quick and build and push, and then I'll get out of here because I think we're already an hour and a half into our session. So let's go back to our handler, and let's just update here in this first little snippet our status. And we're going to actually look at the SDK, which is really, really important because this is really what the value of this whole piece of software is moving forward. Okay, so what we want to do here is we want to do o.status is equal to we have a true configuration, and then let's go back over here and we can set our status equal to we have a false configuration over here. And usually when you're looking at operators, you're going to see that the different statuses are defined as like constants, and they have a big documentation blob on top, which we can look at like the memcached one here in a second and actually see that we have a very mature definition of what each of these statuses mean. But the status is going to be important because we can write other operators to trigger off this operator or other pieces of code to trigger off this operator based on some sort of clearly understood status that's important to humans. In this case, I'm just setting it to an arbitrary string. So maybe we could do a status code or a status number as well. Again, this is just tooling to help us as software engineers write better, mature operators. Okay, so then down here at the end, we want to do sdk.update. Okay, so let's look at this really quick. So in the SDK package here in our handler, we have all of these handy convenience methods that are kind of already built out for us. So we can do update, we can do create, we can do delete, we can get, we can even list, we can do delete operations, we can even watch. And this is really like our toolbox as an operator engineer for actually interacting with various parts of Kubernetes. Here in our rback.yaml file, we define various resources that are available to different API groups. In this case, the TGIK.Heptio.com is open to all resources with all verbs. And of course, this rback definition is going to explain, or express rather, what we can and can't do here and what types of objects we can and cannot pass into update or create or get. So if we have read on an object, we should be able to get it, so on and so forth. So you can really start to build out like mature configurations of what exactly you want your operator to do and only allow it to do those things. So here we're going to do update, and we're going to pass in our object, which is simply O, and we should be off to the races. So let's go back here really quick. We will do a build, an O build. Actually, we need to do an O generate first. Actually, we shouldn't need to do an O generate because we didn't change our API. Okay, so we're good here. We just do an O build, and then let's do a Docker push, kill our logs. We'll do kget PO, we'll get that ready. Oop, we don't want KK, we want 1K, kget PO. So we'll kill this one, K delete PO, bam. It was deleted. Let's get our new one here on the left. Get our logs, K logs, -F. Okay, so we have set to true. And if we do kget TGIK, TGIK live true, so now let's do kget TGIK, the name of the TGIK custom resource we want to get, kget TGIK, and then let's do OYAML. Bam. Okay, so here we have an updated status. So this is really cool. So now our status, which actually has a capital S here, so I probably messed up my JSON definition in our fields if we go look here. This looks to be, yeah, that's why. Okay, so that was invalid syntax, so that's why we have a capital S there. But either way, we now have a true configuration. So now we've been able to demonstrate that we can flip a bit, take some custom action on our operator, and do pretty much anything we can do in Go proper, but just in the context of running as an operator in Kubernetes. And then we can update a status that says, yes, something meaningful happened. So already, like the first time I kind of went through this process, I was like, man, like I can really go and start writing operators for everything. Like I could write a tweet operator where I define a tweet as a custom resource. And every time I want to tweet, I just insert new message, and it'll handle all my authentication for me, and then go send a message off to the Twitter API and actually tweet something out there. But you can start to explore different ideas for managing your software at a higher level as an operator and starting to do complex things like, again, I keep going back to the MySQL example, but using like MySQL bin replication or spinning up a new slave or even migrating data from one MySQL to the other or MySQL dump. But you can start to like have these higher level concepts that are managed by software that are defined by a CR. And to me, that's like the operator in its entirety. So anyway, the operator framework makes this really easy for us. I was able to basically build an operator from the ground up here in an hour and a half live on TGIK, update a status, and update our API configuration moving forward. So that's an hour and a half, which is where I'm going to cut it off. So if anybody has any questions or if they want to see anything after the episode, hit me up on Slack, hit me up on Twitter. I'm in all the places, Kubernetes, Twitter, Heptio. You can email me. You can add an issue to the TGIK repository. And thanks for joining, everyone. I think Joe's going to be back next week. I'm going to be away in Iceland talking in GopherCon EU, so I'll probably be like in the middle of the night falling asleep or climbing a mountain or something while Joe's doing TGIK next week. No idea what he's going to be doing it on, but feel free to open up an issue in the issue tracker, and we'll see everyone next week. Thanks for joining, folks. And I'm going to say goodbye really quick because I know we have a little bit of delay as I talk and folks start saying goodbye. So thanks, Steve says, thanks, Kris Nova. Keith says, great episode. Thanks, Chris. Moody says, thank you. Again, it's been wonderful seeing everyone. Thank you for joining. It means the world to us. And we'll see everybody next week. Thanks again.